In this problem, you're going to be doing a little experiment on yourself. You're going to be determining the maximum and minimum focal length of the lens in your eye. If you didn't already know, I just spoiled it for you. Each of your eyes has a lens in it. And if you'll recall, in a previous video, or perhaps you noticed in the content, I mentioned that the focal length of a lens, or really of any optic, is determined by the curvature. Determined by the curvature. Now this is a hard lens, and that means its focal length is not going to change because its curvature isn't going to change. So whatever value it is, that's what it will always be. The lenses that are in your eyes, they're soft lenses. That means their curvature can change, and so the focal length can change. That's important because in your eye, the image distance is fixed. It's about 1.7 centimeters. That's the distance from the lens in your eye to where the image is formed. And of course, the image is formed on the retina. So your eye doesn't really change shape in any significant way. So consequently, that distance from the retina to the lens, that's fixed. And again, it's approximately 1.7 centimeters. We're going to take that as an average because I don't want people trying to measure the diameters of their eyeballs. So what you're going to do first, we're going to get the minimum focal length. You are going to hold something up close to your eye and as close as you can get it, and it still be in focus. And that's crucial because we're interested in focused image, not blurry images. We want focused images. So first off, if you're wearing glasses or contacts, you can keep them on if you want. That just means the focal length you get will be an effective focal length. That's fine, it's not that big a deal. Or you could take them off. And what you want to do is, again, you want to get as close to your eye as you can. Now, of course, you got to close one eye or cover it up. So I'll do that for my left eye and keep my right eye open. You want as close as you can get and it still be in focus. You're the judge, of course, but for me, that's roughly around there. Okay, so then get a ruler and you want to measure the distance to your eye. Now, don't poke your eye out. We're just getting an estimate here. Try to make it a good one, but a good faith measurement. So just take it like this, kind of get it right there and just kind of see how close it is. Get the measurement, record that into WebAssign. WebAssign is set up, in this problem it's set up anyway, to accept a range of values. So as long as your value isn't essentially impossible, it's going to accept it as correct. Then you can go through, calculate the focal length and the magnification, because now you know the object distance, and again, the image distance is going to be that 1.7 centimeters. Now, to get the maximum focal length, instead of looking at something that's up close, you need to look at something that's far away. And so the question is, all right, what's the furthest thing that you can see? Something that's really, really far away. What's the furthest thing you can see? Now, don't limit ourselves to something like what can you see in a room? I mean, obviously, this is an obstructed view. We're talking about an unobstructed view, where it's nice and crisp and clear. It's ideal conditions. What's the furthest object that you can see? And I've given you a list of things in the problem, so you can just look at the list and pick the correct answer, and then find the distance. You may have to look it up, and you do want to express it in kilometers or meters or centimeters, whatever, and you may have to do a conversion to get that, but that's how you should be expressing that distance. And again, it's going to accept a range of answers, so as long as your answer falls within the range, then that's going to be fine. Then you know your object distance. Again, you know the image distance, that's the 1.7 centimeters, and so you can easily calculate the focal length and magnification of your eye. That'll be the max focal length, and then the magnification for that situation.